So when we talked about choosing a sample from some sort of a frame, and a frame is defined from a population so that we could then make inferences about the population based upon what we learn from the sample. When we choose our sample, we showed just simple random sampling, and we saw that for finite and also infinite populations way up here at the beginning. And, there's a finite population and an infinite population. And so for the finite, we just gave them a random number and then ordered them and took the 5 smallest ones. That's for a finite population. For an infinite population, basically, we just randomly chose them and tried to make the selection independently, and making sure that each selection comes from the population of interest. So that was okay, kind of anticlimactic and not very profound. But that's okay. But I don't know. To me, it's kind of presented in statistics in a complicated way. That's really simple. Am I missing something? All right. So there's other ways we could choose our samples other than just randomly pulling them. And so these are the other ways. We're going to take a look at them. And so stratified random sampling is when you divide the population into groups of elements called strata. Each element, and so examples of that would be putting people into groups based upon department or location or age or industry type. So, hey, everybody who is in accounting, go over there. Everybody in finance, go over there. Everybody in marketing, go over there. Everybody in sales, go over there. Management, go over there, right? And then, or you could say, let's choose people by zip code, or let's choose people by age, right? So those are different strata. And each element of the population belongs to one and only one stratum. And best results are obtained when the elements within each stratum are as much alike as possible. So you have homogeneous groups in each stratum. A simple random sample is then taken from each stratum, and then you can combine the stratum sample results into one population parameter estimate. The advantage of strata are homogeneous. This method is as precise as simple random sampling, but with a smaller total sample size. So that might be why you'd want to do it. Cluster sampling, and I'm just going to as precise as simple random sampling, okay, which is what we were already looking at. Here's cluster sampling. So we looked at stratified. Here's cluster. The population is divided, and cluster is a lot like strata to me. Population is divided into separate groups of elements called clusters. And an example is primary application is area sampling, where clusters are city blocks or other well-defined areas. That, to me, sounds a whole lot like strata by location. But, okay, maybe you have to get further in statistics to really understand the nuances there. But ideally, each cluster is representative, small scale version of the population. A simple random sample of the clusters is then taken. Right? Simple random sample of each cluster. All elements within each sample chosen cluster form the sample. And advantage, the close proximity of elements can be cost effective. So many sample observations can be attained in a short time if you're clustering people by city blocks. You just have somebody walk each city block. This method generally requires a larger total sample size than simple or stratified random sampling. Yeah, so that's cluster. And then systematic sampling. If a sample size of n is desired from a population containing n elements, we might sample one element for every n out of n elements in the population. So if we had a population of 1,000 and we wanted 30, well, let's say 100, we would have 1,000 over 100 or 10, right? So we'd sample one element for every 10 elements in the population. And if we did that 100 times for a sample, right, then one element for every 10, 100 times is 1,000, which is the population. We randomly select one of the first elements from the population, then we then select every 10th element or whatever that follows in the population list. And so it's you just, I'm going to choose every 10th person that comes through the store or whatever. This method has the properties of a simple random sample, especially if the list of the population elements is a random ordering. The sample usually will be easier to identify than it would be if simple random sampling were used. And selecting every 100th listing in a telephone book after the first randomly selected listing is an example. So that's systematic sampling, right? We've seen these. Now we're going to look at convenience sampling. And convenience sampling is you just sample those that are convenient. Hey, how are you? Come here. I got a sample for. I have a survey for you to take. It is a non-probability sampling technique. Items are included in the sample without known probabilities of being selected. The sample, like, we don't know what the probability of somebody being selected was, right? The sample is identified primarily by convenience. A professor conducting research might use student volunteers to constitute a sample. Sample selection and data collection are easy. It's impossible to determine how representative of the population the sample is. Judgment sampling, the person knowledgeable on the subject of the study selects elements of the population that he or she feels are most representative of the population. It's a non-probability sampling technique. Reporter might sample 3 or 4 senators, judging them as a reflection of the general opinion of the Senate. Right? Advantage, it's a relatively easy way of selecting a sample. The quality of the sample results depends on the judgment of the person selecting the sample. So that's different ways you could do sampling.